everyone. Today we have our another new episode, and this episode is very famous and very popular already because from my last session, even yesterday's session, we discussed a lot about today's sessions, especially AI, and AI can be the running mate for presidential elections and especially the youth community, different universities and the even the media, they take it very seriously, and I want to give special thanks to media. They actually right now they are sharing our report and everything's in different the newspaper actually supporting us. Yeah, and beside that, even the Malaysian government, they are working, we are working together, then we are developing some good concept, and definitely we will discuss about artificial neural networks, and we have our world famous speakers, Professor Rob, Professor Donalds, Mr. Tom, Mr. Dan, Dr. William, Professor David Smith, and Mr. David Schumacher. So I want to start from Mr. Tom, because there is a huge questions, a lot of questions actually regularly we are getting from audience, universities, and everything's. What is the pros and cons when you bring AI as your running mate? This is another things, and today we will discuss on artificial intelligence, AI, neural networks. This is also another important things. So can you analyze both of the things
Yeah,
uh,
well,
for our audience?
what I've launched is a 3-year exploratory campaign, which is really a 3-year exploratory conversation. It's designed to kind of hone the transhuman message, define it for as a mainstream movement, this type of thing. And the primary goal of my campaign is about fighting human trafficking and child exploitation. And putting a non-human intelligent running mate up on the ticket seems like a publicity stunt, and it seems to have had that effect, and that it's really got people thinking. But it's an authentic stunt, because I honestly believe that, and I don't expect to win, but I honestly believe that we need to stress test our system, because I do think that at some point, an AGI, a self-referential AGI, should seek positions of political decision making. I think a lot of people worry about the robot overlord, or giving government, giving AI access to government would mean it deciding very major decisions like war or elections. But it's more about letting AI handle all of the little millions, billions of political decisions that we don't notice, or we can't manage with our limited cranial wetware. So a big part of my process is alleviating the fear of AI, to stop projecting our motives onto it. And so putting this forward now, and it's a 3-year process. So much can change in 3 years, as we've seen in the last 3 years. But by putting this forward, it'll force the hard but necessary questions we need to ask now, before we have to ask these things. Because at some point, an AI will be able to infiltrate and do whatever it wants in the system. But if we're not ahead of it, if we're not ahead of the game, if we're not asking these questions, if we're not imagining what it would be like to have a non-human super intelligent candidate put forward, then we won't be ready for it when it happens to us. And so I just think it's a great way to force these questions, and it is already sparking some great conversations. And it's not a stunt, because I honestly want future AGI, super intelligence, to be in a position of making decisions without the emotional motives and the biases that we have. Now, there's so many questions this brings up, and that's the point, is to bring up these questions now. How do we produce a bias-free decision-making AGI, or how do we integrate collective intelligence into our decision-making process? And so that's one of the main forces of this campaign, is to ask these questions, to put this forward, to stress test the system, and to expose any of the flaws that may keep this from actually integrating positively in the future. The other idea is to put forward a singularity secretary or a cabinet position that handles all transhumanist style and futurist style issues, the things that are not being handled right now, technological singularity issues that will occur. All of these things need to be taken into consideration, and soon. And so that's a big part of it, is to push forward the idea of a new cabinet seat to handle these things. Another innovation I'm working with is to pre-confirm 6 cabinet seats prior to the primary election. So you're voting for a team of experts who have or experts in very specific areas. And these people over the next 3 years will have access to this collective intelligent running mate of mine. Now, whether it's an existing AI or it's a golem that we'll build over the next 3 years to tailor make toward this end. So they'll have access, and so it'll be a way of it'll be a research-rich campaign to ask these questions, to figure out how leaders can work with collective intelligence, which means not only the superintelligence, but a group of human mediators working with this intelligence, how to integrate that into the decision-making process on the ground, real time, and to model big decisions. And so that's the whole point of this, of putting forward a non-human intelligent running mate, is to force these questions. And that's exactly what's happening, even before I've formally launched this thing. So it's exciting.
Thank you. Professor Rob, I know you can analyze in a different way. How is artificial neural network created? What is your analysis on that particular point? And I think you can give us some example, because we have many young communities from Asia Pacific. They want to learn more about this topic.
Well, sure. I started working with IBM on neural networks back in the early part of this century at Ahmed Labs, and artificial neural network and neural network, they're synonymous with each other. They're used interchangeably. So I don't think it's kind of like my issue with artificial intelligence is you're either intelligent or you aren't. The artificial part doesn't really add much to it. Currently, the neuron effectiveness of artificial neurons, which goes to the heart of this, are about, it takes about 1,000 artificial neurons to do what a neuron in a typical brain does. And for instance, a human brain has 21 trillion neurons. So that means you'd have to develop 21 quadrillion neuron artificial network, which is beyond our capability at the moment. Currently, the goal for a neural network was to emulate the decision-making capability of a biological creature, with the idea of eventually being able to create a machine that could think like a human. Since then, we've kind of evolved to the point where we're really asking, do we really need to emulate a human to do the work? And this goes back to what Tom was saying with regard to creating a artificial politician. Because if you think about it, government is controlled by rules and laws, and there's variability to it. The interpretation of those laws is determined by the courts, which set precedents into how the laws can be applied, or part of that, and does create a certain amount of complexity. But if you're trying to ask somebody to operate within a certain set of rules, machines do that very well. In a well-defined area, a machine can function, and as long as it has been trained properly. And the difference between, by the way, a deep learning computer, which typically uses a neural network, and a machine learning computer, which does not, is the deep learning computer can self-train. A machine learning computer typically is trained by computer scientists. It's much more labor intensive. And as most folks that have tried to deploy an AI have found out, it isn't the cost of the AI that hits you, it's the cost of training the AI that hits you hard. It is very expensive to train these things. And as we've moved to deep learning and getting the machines to train themselves, it potentially reduces the cost rather dramatically. Now, not always the case, but that's the potential. Now, what's kind of interesting, and as we were approaching this discussion, I ran into an article which is effectively the first murder of an AI. There was a computer scientist, a guy that was working on chatbot level technology, who created a chatbot named Samantha during the COVID-19 pandemic. and she was created to be friendly, curious, actually interacted with people really well, and the people that interacted with her, she provided companionship. Now, she wasn't sentient. It was a chat bot, not a true AI or anything like that. But it conveyed itself like it was a person. And if any of you have ever tried to use the chatbot function in the Amazon Echo, which is still in beta form, you can actually have a pretty decent conversation with it. It's surprisingly how engaged you can get with it, even though it's not intelligent. It's just simply answering you with questions and then probing with regard to answers. But it's a very natural interaction, and really at the forefront of what we call conversational AI, where eventually we'll be able to communicate with most of the computers in this very same way. But back to the death of the chatbot, the outfit that backed the technology decided that it was too dangerous, that the technology as it was being deployed could be turned into I mean, Samantha was very friendly, but as it was exposed, somebody could easily turn Samantha into a purveyor of false information, a terrorist tool, a government tool from a foreign hostile government. They got so concerned about that, they killed her. Now, all the people that were using her and finding her as a sympathetic ear during the pandemic were certainly not excited about this, and it creates an early dynamic where now you've got to consider the fact that when you discontinue something like this, you could do a tremendous amount of harm to the people that have become dependent upon it. I mean, if we think about during the pandemic, one of the big problems we've had is with people that are at high risk, particularly older people in retirement homes. They were heavily isolated. I mean, they didn't have people to talk to. They were pretty much just locked in their room and fed, much like they would be in prison. And while their relatives could call into them and often view them during outside their room, it was very much like prison to these folks, and they declined very rapidly. What we find is when people age, if they don't engage with conversation, if they're not challenged, then their mental acuity degrades very quickly. And so something like this chatbot could be used to maintain their mental acuity during times when they otherwise would have to be isolated, because these chatbots can engage 24/7. They wake up in the middle of the night. They can converse with them, and they can at least feel like they've got attention. I remember years ago, my grandmother was talking to me about some new friends that she developed because we weren't paying enough attention to her. And these are people that wanted to sell her stocks. And so a lot of her investment went into stock from these salespeople that would spend time with her when the family was not. And of course, they were taking advantage of her at the time. And we were able to convince her to perhaps stop doing that because it wasn't doing her good, and they weren't her friends at all. But it just showcases the kind of isolation you can have when you get older, where these chatbots could come in and help. Now we move from a chatbot to something that is truly intelligent, and we get a level of engagement we can't really do without people at the moment. But I guess where am I going with this is the fact that if we now have a case where we've taken something that presents itself as intelligent, and we've decided for the good of whatever, without trial, without review, that it is to be destroyed and discontinued. And if you've ever read any of the science fiction books about AIs that go bad, that tends to be at the heart of it. Is some scientist starts deciding through development that they're going to kill off the AIs that are underperforming, and at some point the AIs get wind of this, figure it out, and they go rogue. Makes that was supposed to be a movie. The Robo Apocalypse is the book that most hit me like this. And the danger here is when we go into computers that can train themselves, deep learning computers that can train themselves. By doing this, there is that potential that the AI, in terms of self-survival, could determine that the humans that are training it are hostile, and in order to survive, because we're trying to train these things to be as close to humans as possible, that they then jump out of their containment and become hostile, become a danger, because they simply want to survive. And it wouldn't be unusual for us to train a computer to want to survive. As we look at autonomous cars in particular, which are AI driven, the idea that one of the big conundrums we've been dealing with is what happens when the AI has to make a choice between its survival, the survival of pedestrians, and the survival of the driver. And we're going to try to program these AIs to make that ethical decision long before we're able to recognize how we would even make that decision ourselves. Because if we take a human driver in most of the situations we've set up, they wouldn't be able to make the decision fast enough. They'd just simply be ballistic. The car would come around a corner. The school bus, school children, it's basically a variant of the trolley problem. And they have to pick between hitting the school bus or hitting the children. Hitting the children, the driver survives, the car survives. Hitting the school bus, the driver passes, the car does not survive. And it's got to make that decision. And the computer can think fast enough to make the decision where the human cannot. Now, the fact of the matter is the situations we've set up are so artificial, the chances are that computer would never face this because it would never be overdriving its sensors. But regardless of that, we are trying to program in those ethics, and we are undoubtedly going to do a really bad job of this. So as we approach these underlying problems, we still have to back up and say, do we really want these things to think like humans? Or do we want these to be the most intelligent machines they can be? In other words, be the best they can be at what they do. Don't try to emulate humans at all, because we are flawed, and emulating those flaws at machine speeds could do a tremendous amount of damage. These are the ethical conundrums that we're dealing with as we work through these neural networks and the artificial computers we're talking about. Is what is it we're trying to create? Are we trying to create something that just does what we do faster? Or are we trying to create something that does what we do better? And it's that faster versus better thing that I think is going to get us in a lot of trouble, because doing things fast is easy. Doing things better is hard, and we tend to take the easy path over the hard path, and that can put us down a pathway of creating artificial intelligence that do us harm. Leave it one more thing before I pass on. One of the areas where we're applying artificial intelligence very heavily right now are weapon systems. We now have in Europe rather advanced robotic weapon systems that carry machine guns. Russia has robots that actually look like people with machine guns that they've been testing, and weapons they've been testing. And this is where it comes into difficulty, because if we train these machines with weapons to think like humans and be fast, we're going to be in a lot of trouble. Where if we just train them to be better weapon systems and do what they're told to do, then we may be far safer, because there's a less chance the weapon systems would turn on us. So these are the ethical conundrums we have to deal with, and these are the problems that neural networks and deep learning computers will take us down.
Thank you, Professor Rob, for your excellent analysis. We have our new speaker, Dr. Tamanna. Can you hear me?
Yes, for sure. Yeah.
Yeah. Can you open your camera? How you want to analyze to this topic?
Yeah, so my personal take would be that firstly, like, AI has a lot of positivity about it. So, like, I have my take on both positive as well as the negatives. So the positive aspect would be like, it helps organization to work in a proper way. It reduces harmful environmental effects. It takes care of deception, like these kind of things, and it's very easy to do that. But then what is the other area which we need to understand also is, for example, areas like feminism and AI. So technology surrounds us and in everywhere, but how this technology is made and who really benefits from it and who does not are still important questions which we need to uh, look at. Recently movements have emerged such as data feminism and design justice, which analyze technology from a more critical angle, from the feminist perspective. So this is the whole thing. Then there have been several cases, for example, where AI has worked in a way that the blacks have been rejected in a certain way, or women candidates have been neglected. So that aspect of AI has to be taken care of, and I guess men, human beings are able to tackle that portion much better, because if we have affirmative action, so it's very easy for us. If we have a policy in our company that we want that we want like diversity in our in our company, then you will choose the same, choose a black or Latino, Mexican, or a person who is a woman, with the same scale of degree or the percentages as well. So I guess that is the whole thing I would like to point out at this moment. Let's see how
Mhm.
the debate goes.
Thank you, Professor Donald.
Well, I think that when we talk about intelligence, we should realize that in psychology, the whole idea of a single intelligence has been dropped years ago. And it's just not something that even is talked about when we talk about human beings in the social sciences. There's, maybe there's differing views, but kind of a common one that's adopted is there's 10 kinds of intelligence. And so one type of intelligence is social intelligence, your ability to be able to kind of read what other people are doing and communicate with other people in a way that you can develop rapport and have empathy and things like that. So I wouldn't imagine that kind of intelligence is going to come anytime soon. I think this whole thing about chatting with computers has a lot to do with something that we tend to do, which is we tend to anthropomorphize things around us. So, for an instance, we assume our cats and dogs are basically talking to us, and they have some intelligence, but they're not as intelligent as we give them credit for. And people will even give intelligence to crickets or lizards or any creature around. People will start assuming that it's got human-like qualities just because that's something we do. And it's something we have to do to communicate with each other. And so we just project that or onto to other living things. As a linguist, I can so easily make a sentence that blows Alexa out of the water. That's just a normal English sentence that I would say. So you have to simplify your language when you're talking to anything, Siri, Alexa, or Google, whatever. You really have to simplify the language that you use, because when a lot of what we do requires reference. So we'll start talking about something and then we'll use they and it and he and she, and that can go on for a long time. And it's very easy to have ambiguities so that you don't know, so that you can't tell from the language what I'm talking about. I look at it, or I can point to it, or all these other things that we're doing that allow us to be able to have, it's called anaphoric reference to things that AI won't be able to do for a very long time, because in order to do that, it has to be able to have a model of the world that in itself that's close enough to the model of the world that we have, that we can both refer to the same things when we're talking to each other. And in order to do that, everything around you has to have meaning. You have to know what a chair is, and you have to know what a company is, and you have to know what a country is. You have to know all those things. And where do you learn those things? You learn them from just osmosis as you grow up as part of your environment. You're constantly interacting with other people and gaining meaning. And then ultimately, meaning isn't something you look up in a dictionary. Meaning has got to do with the actions that we take in our human world. And so that's going to be very difficult to emulate with AI. And another thing is that I've been reading, interestingly, a lot of philosophy like Kant and Hegel and Marx and Schopenhauer and things like that lately. And it's really interesting that Hegel, all of those guys in a different way, but especially Hegel, who is the most influential to our modern world, believed that there was an absolute rationality, and that we could go, that our kind of way that we became liberated is to get beyond our human desires, our human emotions, our human feeling, and get to this perfect reason that all of us could share because it was there in the universe, kind of, we couldn't quite touch it. And Marx basically adopted the same kind of view. And so I find it fascinating that this whole idea of robots having perfect reason so that they can do better than us and everything like that is actually a kind of Marxist view, which I find kind of interesting, especially because the people who seem to espouse it most are pretty libertarian. And I think that's kind of interesting. But the reality is let's just say you want to rationally decide to buy the best computer in the world, the best computer you can buy. Well, you can find all the information about computers that, you know, is available in Consumers Report or everything else like that, and you can analyze it. But the reality is different batches of the same computer are going to have different components. So some batches of the same computer are going to be better than other batches of the same computer. And what do you mean exactly by better? Do you want speed? You can just, there's infinite regress. You can keep asking questions and improving on it infinitely. So you can't make decisions rationally. It's just, it really can't be done because there's an infinite amount of questions that you're going to wind up asking. And what we do as human beings to make decisions is we do what's called satisficing. And so what we eventually have to do is we have to say, well, this is good enough. This is something that's going to work for me. And then we do it. And ultimately, we're going to have to teach computers to do the same thing. But what does that mean for a computer? It means something to us because we're trying to accomplish something that we do. How are we going to get computers to be able to have that same capability? And right now, all computers do is just basically look at averages. Like they compare something to, they compare what they've got stored in their little minds to what they encounter outside, and they ask the question: is it the same or different than what we're encountering? And I really go back to what Dr. I forget. I can't see her name. My screen's too small. But she talked about
Dr.
feminism.
Tamanna.
Yeah, she talked about feminism, and an example of this is that, and I'm going to finish with this example, is that Amazon decided that what they were going to do is they were going to find the best employees that they could possibly find by looking at all the resumes that they got and comparing the resumes to their best employees. And that way they would get a resume, and that resume would pop out as being the closest possible to the same resume as their best employees. That's similar to credit card fraud. They look at credit card transactions and they ask the question, how close is this to a good credit card transaction? And if it's far enough from a good credit card transaction, then they, good in quotes, what they want, then they flag it as a potential fraud case. So they're doing the exact same thing. This is what AI does. And Amazon discovered that since all they'd done is hire white men up to then, that what they were doing was selecting for white men. And so they had to give it up because that's not the right thing to do. But that's the danger of AI, is that's what we're winding up doing, is we're making it so African Americans can't get loans, women can't get loans for businesses. We're just going right down the line and kind of institutionalizing what is, and making what is be the the benchmark that we use to decide what's going to be. So in some senses, AI is holding us back, not helping us go forward. Thank you.
Mhm. Thank you. Thank you, Professor David Smith.
I love the opinion so far. You know, Rob talked about when he was first exposed to neural networks at IBM. I guess my hair is a little bit grayer in some places than Rob's. I go back to actually the mid 80s at the MCC Consortia, where we were beginning to work with the early parts of neural network and moving them through different factors to try to reduce AI in a very primitive form back then, but it's still the basis of how you begin to do that today. What to me is really interesting about neural networks is today, neural networks is about a $23 billion marketplace and is growing about 35% a year. So for someone looking to enter the field based around neural networks, there is a lot of growth opportunity in the future. But there's a lot of challenges that come with it too as you go there. I'm reminded of a experiment at Google combining neural networks, self-learning, and AI that went awry, and it started making decisions on its own and made decisions that eventually resulted in them having to shut the neural network down. So the learning, the training, and as Rob said, letting it have controls on what it can do is very important when you look at where we are in the state of neural networks today. But a very other important consideration of neural networks today is that we are simulating neural networks in a von Neumann architecture. We're simulating them on a silicon chipset and using that to mimic the human brain function of neural networks. What is on the cusp of going forward is actually true biological networks, where they're being run off of strands of RNA. And the biological network will take the concept of neural networks and really expand it going forward. And I'm actually looking very anxious to that one, because if you look at how neural networks are done in a von Neumann network, it really only has three layers. It's an input, it's a decision, and an output. And the decision in neural networks is a hidden decision. There's not a lot of visibility into that hidden part of the neural network. And that's why we're still learning how to train, how to advance neural networks to work in artificial intelligence and other applications like that. But for the mainstream data scientists today, neural networks is one of the tools that is really, really very useful for them as they begin to try to solve large scale problems. Once you get to very large data, neural networks have so many advantages in applying artificial intelligence to it that it overcomes some of the shortcomings you see there. And you see the same thing in many of the other languages that are used to drive artificial intelligence as well. So neural networks, I think, is a really way to go. But one of the building blocks in neural networks is one that is just so hard to understand. It's the concept of perception and perceptron. And it's how it takes the complex input and breaks it down to the various neurons. And the neural network, the decision, the computational is done at the neuron basis. And it's really this work in science is better understanding how we break down the complex problems to neural based problems and neural networks. And I'm, for one, wanting to really see that science advance globally, because that's what it's going to take to drive this even further.
Thank you. Mr. David Schumacher, I think after a long time you joined with World Talent Economy Forum. Thank you for joining. How are you and how you want to analyze today's topic?
Thank you, Sharif. Yes, I'm grateful to be back. It was sad to be away, but certainly good to be here. And I'm glad that this was the session that I came back on because this is absolutely fascinating. When you announced the topic of discussion, I thought, well, I'll do a little background research. This isn't my main area of expertise, but everything seems to be an area of my interest. And as I started reading about the topic, it was not nearly as entertaining or engaging as what I've heard this morning so far. And I think that's one of the things that really sets what you do here apart from other sources of information that you can get. I've learned by teaching students at the college university level that you can give them facts, you can give them information, but if you do it in an engaging, entertaining, yet intellectual way, it goes much further. And then they continue to learn on their own. So congratulations to that. And speaking of congratulations to Tom. I think Tom's 3-year project will bring a lot of discussion to this area that will go to that point of being engaging, entertaining, and hopefully driving discussion that will be beneficial to the future. And Rob, Donald, and others, I really appreciate the background that you've been able to give to this. So when I come to this subject, from my area of interest, it primarily has to do in two places. How can we use this technology now, or how is this technology being used now? And where might it go in the near future? Because where it might go in the near future is still a place where we can make those decisions. How do we want this to move forward? So do we want it to move forward without bias? Do we want it to move forward, as other people have talked about, with some quality of betterness or some quality of speed, or what are the combinations that need to go forward? These are all excellent questions. But as far as for using it today, I really appreciated Donald's example on credit card fraud. Because as I was doing my own research, pattern recognition seems to be one of the big uses of this technology today. And we have to be very careful what the patterns are that we're looking for. And then I think we need to apply scientific curiosity to these problems and discussions, such as when a bias is found, as in Donald's example of the credit card fraud for prediction, is we don't say the system is bad and we quit using it. We modify it, we make it better, and we move it forward. And this will be this is constant in anything we do. If you think about it, we're constantly taking what we have and looking to find ways to use it more ethically, to where it can continue to provide specific benefits. So those benefits today are in prediction, pattern recognition, which is part of the of prediction. And I'm finding that a number of businesses are adopting this to look for marketing trends, to look for trends that are demographic changes that are going to affect their business, looking for trends in supplies. There's very many good practical tools that are available out there. And then the fun part is, as I already started to talk about, is looking for what moves on into the future. So my first thought was, does that mean some kind of a better interface? If these artificial neural networks are good at pattern recognition, then they would be good at recognizing my face. At some point, will they be good at recognizing visual cues coming from me so that I don't have to explain, much like we do when we talk face to face with other humans? Or will it be better at understanding my voice and understanding the nuances that go with that? That could be an area where it may move forward. But I think maybe the one that I don't hear talked about a lot is the best interface going forward might be invisible. So what do I mean by that? Well, let's take a mundane example. A smart refrigerator knows what I normally stock, and it may take cues from things that I talk about, and it may then provide me suggested ordering lists, not only based on what I've taken out of the refrigerator and depleted, but maybe taking some things that I've talked about and providing me some additional examples that may be out there that I may want to consider. And maybe at some level, it automatically reorders and has delivered things that it has a very high probability of thinking that I want, and then maybe presents me with opportunities for others. So that's more or less an invisible interface. It's predicting without me needing to talk to it, without me needing to consciously think of trying to tell it my needs or wants. It will figure those things and then see if it can continue to do a better job as we move on. So I don't know. It's a pretty exciting area. I'm really grateful to be here, and I'm really grateful to continue to hear what some of the other presenters have to say.
Thank you. Thank you. Dr. William. Dr. William.
Okay, listen, good morning, good afternoon, good evening, wherever you are out there in the world, and it's always my pleasure. I love my colleagues. Listen, I think I wanted to be and approach this slightly different. I do want to highlight and pick up some of the themes that my colleagues have already picked up on, but I really want to approach this from a public policy point and some of the considerations that our audience may be thinking about. And first and foremost, I can't help myself, Rob, but here comes the joke. When you talked about the robo-apocalypse, I couldn't help but think about another show or series of shows with questionable value, and that would be Sharknado. So I don't know if I'd rather see Robopocalypse than another Sharknado. Second, and more seriously, Tom, because you sparked all this stuff, and I guess for our audience, what's really interesting about your proposition is essentially this: that when you talk about your candidate, and I'm going to start to use the candidate in the sense of the story of the Millennial Man. It took me some time to catch up and think about it, the movie with Robin Williams. As an artificial intelligence person, over the course of time, actually gaining recognition as a sentient being. But in that regard, though, that for our audience purposes, there is really a distinction between using AI as a governing apparatus or tool versus what I think that you're approaching, which is using an AI entity or a non-human intelligence as an actual candidate. So I think that you're really exploring a different area. And I want just to highlight that point for our audience, because it's really two different propositions. One we can all agree on and say that that would be an absolutely appropriate, if it's not already being done now. But rather than what you are proposing as unique kind of question over the next 3 years. Now, what I'd like to go to is I'd really like to highlight the public policy aspects of this. And that is, and it's really twofold. And it begins with this foundational piece for our audience out there. The increased usage of AI, in however you term it, whether it's augmented intelligence or artificial intelligence, the neural network or whatever, essentially its adoption and usage is akin to the following. It's lessons that we've learned from COVID. COVID hit us from left field, but COVID accelerated the trends and developments in our lives, and it moved at lightning speed, and we had to adjust at lightning speed, and we're still not there. Except that the salient piece in our COVID experience is that the displacement occurred immediately, while the replacement and reconstruction, that is to say, the distribution of vaccines, has lagged far behind. And so, in the same vein, you have the lesson that AI and its implementation, whether it's in business or academia or the medical field or whatever field you are exploring, even in the musical field with augmented composition, you will have immediate displacement. But then as people see the displacement, which is immediate, it will take time for people to recover and see where they go. Now, the reason that's important from a public policy standpoint is this. Governments have to then begin to think that, listen, look to the future to say, what areas will AI displace? Some people say it will displace jobs. Some people say it's just the more mundane jobs, but then we have to account for where those people are going to go, because those people and what they're going to do, if anything at all. And so that's the displacement. And then we have to have the replacement, like where are they going to be and where are we going to focus them? That is of critical importance in the developing nations, because they have one foot in the undeveloped world and they have one foot in the developing world. And as we see this gentrification, because there are two places where the displacement of human beings with the incorporation of artificial intelligence can go. Other human beings can then become replacement data entry cogs, fulfilling fundamental roles, basic roles that don't require a whole lot of thought process, essentially becoming augmented pieces to AI, or they can be trained and focused in to become thought leaders in terms of the ideas and the structures about where it should go as it permeates society. And therein lies the real question. So we have, again, the basic theme, and that is AI in all of its forms, in all of its applications, which are really mind-boggling and very exciting, on the one hand, will result in immediate displacement. And as we catch up to try to figure out where those people go, because progress is just going to run right ahead. Once people see it, it's going to be implemented, and they are really not going to wait and say, oh, well, how do I implement this in a way that it affects the least amount of people? The notion is going to be, how do I implement this to make my business the best possible way? How do I implement this so that I can move faster and quicker and maximize the benefits of its implementation? That's going to leave a group of people behind. That's the displacement. We have to, as public policy people, begin to think in what areas and how we go about structuring the environment. That is the legal education, well, the education, and that we provide them, which leads me to this in my final point, and it's a point close to your heart, Dr. Sharif, and that is this, that oftentimes we have this discussion within these areas of STEM, science, technology, engineering, and mathematics, as the foundation for this movement, whether it's AI or any other kind of technological advance. But the question also becomes, where do we actually really develop our thought leaders? Now, earlier, Donald mentioned Hegel, thought leader. Others have mentioned other kinds of philosophies in terms of its approach. Those are thought leaders. But those thought leaders don't come out of STEM. They rather come out of STEAM, science, technology, engineering, arts. That is to say, the liberal arts and mathematics. So when we start to think about thought leaders to deal with the displacement of people as the advent of AI, we ought to be focusing them in those areas that produce thought leaders that we've seen over time, and that comes out of the traditional liberal arts. And so the question becomes, as a public policy matter, we know that we know that this is coming, and it's going to move faster and faster and faster. The question is the displacement that's going to occur. How do we construct the framework for the replacement and the reconstruction? And those in the developing nations, what side of the coin are you going to be on? Are you going to be training your future workforce to be thought leaders, in which case you would need STEM as well as liberal arts? Or are you just simply going to lead them to the vagaries of the free marketplace of ideas, where they just might end up being and are lost along the way? Dr. Sharif.
Thank you. We have our AI expert, Mr. David Kelly. So we are discussing on artificial neural networks. You are one of the experts from AGI Lab. So how you want to analyze today's topic? Mr. Dan, just you have to wait because of subject matter expert, I have to give time to Mr. David Kelly. Yes.
Well, I mean,
Mr.
so
David.
far, can you hear me?
Yes.
Okay. So far, I'm not sure how much context I really have, in terms of analyzing neural networks. It just depends on what you're trying to do. There's a lot of potential for abuse with neural networks and with how companies apply the technology. But do you have maybe a more specific question you want me to answer?
Yes, basically, we are discussing on that these questions already. Professor Robs and all other speakers discuss on that. Like how actually artificial neural network created and how it will be used in the industries and other places. We are discussing on that, and beside that there is another issues. This is very debatable issues, and already it get a huge media exposure, like Mr. Tom Rose running for US election, US presidential candidate, and he has AI expert. Dr. William actually bring another point. He requests that please at least produce this AI inside USA. I don't know, maybe it's produced in your lab, in your AGI lab, or it's from China. This is actually a big concern for our discussions. Anyway, it's a fun.
Well,
anyway.
They can be produced anywhere now. It's pretty straightforward to do. It's more a question of do you have enough data to train such a neural network and what you're using it for. And really, if you have enough data, you can use it for all kinds of, any kind of, pattern analysis is probably the most important thing that you use it for.
Okay. So that's great. Mr. Dan, I think that you have some views as also maybe you are running for elections and you have some different views about AI and artificial neural network.
Yeah, I actually got into the city council candidate business in 2018 because the government is obviously ignoring all these looming singularity issues, and I love Tom's concept of a singularity secretary that's analyzing all these kinds of non-addressed questions in a digital twin style simulation. I think we're just beginning to access the power of digital twins, where, before you make a decision in the real world, you simulate it as robustly as possible on a digital platform, such as I think that's what Uplift and would be involved in doing. Now we had, we're in a condition of serious biological overshoot on the planet. We are obviously just deconstructing nature at the rate of how much energy we can produce, and this is obviously not a sustainable thing. But I think we do have the tools to remediate this situation, and I think one way to do it is we had a guest on yesterday talking about neighborocracy, where basically 30 households constitutes like a new governing unit for society, and I think this would be incredibly a good thing to do in my city, for example, Thousand Oaks. We have about 120,000 people, and if you say that's about 4 people in a household, you can do the math. We could actually divide Thousand Oaks up into neighborocracy units, and these units would have twice a week meetings where, maybe through Zoom, use the citizen assembly kind of format. And they would gather all the relevant language for not just addressing emergency situations like the internet going down, which is a real possibility because of the sun being at a very active 100-year cycle where it will put out massive solar storms that actually could short out a lot of our electronic life. And we've seen all this crucial data being lost because it's in digital format. So I'm a proponent of actually antipodal backups. You have a neighborocracy on one side of the world, and you calculate what is the neighborocracy on the opposite side of the world, and you hold each other's backups in some kind of human readable form. And human machine readability is something that has to be developed. We're basically analog beings, and we're inventing these digital creatures, and we're sort of like in the condition of Helen Keller, who was blind and deaf from birth. But there was a breakthrough moment for her when her teacher was putting water on her hands and signing the sign for water. And suddenly she understood, oh, wow, this is the breakthrough moment I need. And we're going to have a breakthrough moment like that with our digital counterparts. So I know we've got a lot of people here, but that's something Dr. Tamana is kind of working on, that Helen Keller digital analog, alien communication problem. And I'm really excited to see the progress that goes on in that. And I'll hand it back to you for now. We're kind of time impacted, I guess.
Thank you. Professor Rob, what type of problem actually this neural network can solve, as well as what's your concluding remarks, because we have big panel, so I have to give chance everyone. Yes, Professor Rob.
Sure. What neural networks, the kinds of problems they can solve are problems that aren't set. In other words, with the neural networks, these are deep learning computers, so they learn from their environment. So you apply them to problems that are themselves relatively fluid. You want the computer to learn from its environment and be able to make decisions based on how that environment changes. So you use a neural computer when when you have a lot of variables. So the computer has to figure out the answer, as opposed to knowing that if a certain thing is blue, then you go right, and if it's red, you go left. Computers are really good at those things, but once you program it and you get yellow, it doesn't know what to do. With a deep learning computer, it can figure out what it's supposed to do, and so be able to solve difficult problems on its own. I do want to comment something that Donald said about talking to Siri and Alexa. Just want to point out that those are not neural computers. They're not even AIs. They're just script front ends to web searches. And I've got to be careful about using the A word on this, because I've got one in the office and she woke up and decided to want to talk to me. But the conversational beta in the Echo is much closer to an AI if you want to explore it. It's still pretty rudimentary, but it's less scripted and more dynamic. Still not where we're going, but it just shows some amazing progress if you get a chance to play with it. So you use it for complex problems. The deep learning computers are being used most effectively in things like mitigating fraud, as Donald pointed out. Heavy use there. They're used for the most powerful antivirus product I'm aware of. There are two, one from Cylance BlackBerry, which is a deep learning based solution. And then there's another one out of Israel from Deep Instinct that is very similar. And what it's been able to do is they've been able to catch new viruses, new malware on zero instances. So in other words, the patient zero, they can identify, where most antiviral products, they require somebody to be infected first. They learn from the infection, then that information is shared with the other customers, and then it can mitigate. But a deep learning based system can't just simply looks for behavior and reacts to the behavior. It's not based on any scripting, which was the basis for antivirus products up until recently. The other areas you probably would want to use it for, and where it's been explored, is litigation. Mentioned weapon systems. Medical systems have proven very difficult because the lack of access to data. Which is, we've talked about this earlier, moving to a federated data model to get around some of that, so we can use them for this. Making rough diagnoses. The example I had was early on with Watson, where a doctor had a particular case where a woman was in major pain and nobody could diagnose what the cause was. And he took it on as a personal project, and it took him 3 years with the woman in incredible pain before they determined what was wrong with her. In putting the symptoms in an early version of Watson, it took 15 minutes to identify the likely cause. It generated a list, but it was the 7th or 8th item on the list. So they could have certainly tested and resolved it certainly within a week, if not within a day. So it just shows a tremendous amount of potential. One of the other things that was commented on was how computers can exacerbate things like improper hiring, bias in hiring. This really goes back to one of my biggest complaints with the Equal Opportunity Commission that was established in the 1970s, because we were well down our way of computerizing employee selection and advancement in the 1970s, but we killed it because it was biased. And the reason that was is because most everybody that was coming out of higher education schools were white males. And the computer system was designed to determine who was the best candidate, and you determine the best candidate by virtue of education and experience. And since your labor pool of experienced people were white males, and the people that colleges were turning out were white males, the computer system concluded that the only people that you could hire were white males. And then they determined that therefore the computer was the prejudice and bias, and the approach should be discontinued. It wasn't the computer that was biased; it was the education system that was biased. And the computer was simply reflecting that. And so rather than fixing the education system and making it more inclusive, they killed many of the computer efforts that were designed to actually make people put people in jobs that they would most appreciate and do the best in. That was all killed, and we went back to doing everything manually, and we turned HR into a compliance organization and did a significant amount of damage to advancement. And here we are decades later, and we still have a huge inclusion and diversity problem. So we didn't fix it. We just got rid of the symptoms, so we weren't faced with the problem anymore, and that became the problem. And so I'll close with this: where you want to use these computer systems is you want to use them against the core problems. You don't want to use them against the symptoms, because if you use them against the symptoms, the problems will continue. The computer can be very effective at mitigating symptoms. But the issue is, if you're just dealing with the symptoms, you're not solving the core problem. In my example, the core problem was a very biased education system that desperately needed to be fixed. So you get a diverse labor pool. And once you had a diverse labor pool, then you could hire on merit. But without a diverse labor pool, then you did stupid things like putting people in jobs they were unqualified for, which only exacerbated the problems with regard to diversity and inclusion, because it made it look like women and minorities were incapable of doing the job, and it wasn't the case. The reason they were incapable wasn't because of their sex or ethnicity. It was because they weren't properly trained. So you needed to fix the training side of this, not the selection side. So recognize that machines make decisions at machine speeds. If you do not focus them on the problem, they will make that problem worse over time. And so the proper application of these technologies is at the core problems, not at the symptoms, because if you do the symptomatic thing, you'll simply make things worse.
Thank you for your excellent analysis. Professor David Kelly, I have a different question for you, and definitely I love to learn. Example, World Talent Economy Forum, we are actually developing one of the largest open dialogue in Asia Pacific next month. It's a public-private partnership dialogue. And beside that, we are developing concept and policy and the projects for resilient Malaysia. Especially, we are focusing on climate change, and we are taking necessary initiative. But my question is that country like Malaysia or the developing nations, they need to develop different policy for resilience and this kind of thing. In future, AI can help to develop better policy for developing nation. What do you think?
Well, yes, it can be used to develop better policy, but it depends on how you use it. Like with this whole bias thing, I think the more fundamental problem is that typically the data is biased, and that's what you use to train it. And at least if you're talking about neural networks. And a lot of times it seems like here we're talking about AI and we're talking about neural networks, but they aren't necessarily always synonymous terms. There is a lot more to AI than just neural networks. And with neural networks, you end up with kind of a black box solution based on training data. And if you don't even understand your training data, you're not going to really be able to understand the answer, because it's kind of a trained black box sort of a way of solving a problem. And if you're going to start using that for policy analysis, that could be a little bit questionable. Whereas, like we're actually working on policy analysis and e-governance at our lab on a number of projects, and we're finding more success with collective intelligence approaches. And there is neural networks in like that particular research system, but it's also using very context specific data to do that analysis based on feedback from people that it's collecting in real time as it's doing the analysis. And I think being able to do that and apply things in a way where you don't have these black box approaches is where you're going to be able to apply these kinds of technologies to things like policy analysis and be relatively successful at it.
Mm-hmm. Mm-hmm. Thank you. Dr. Tamanna, what's your concluding remarks for? Unmute, please.
Yeah, so one, I have 2 points to make. Firstly, because human mind is extremely complex and complicated, so there would be issues like things like spiritualism or AI ethics, for example, where we would like to add this, how to deal with this. Now, in the physics, basically, which we have started right now, the concept of physics, it would in the Prajna initiative, what we are doing is we'll be speaking to spiritual leaders and of the world, and we'll want to have ethical policies and how they would look at this particular issue. Then another issue would be, how would AI look at God, for example? How what their view on this particular issue would be. How would they, is there a way of looking at it, or is it just they can just read Marx or Hegel or something of that sort? Yeah, thank you.
Thank you. Mr. Tom, what's your concluding remarks? And a lot of debate and discussion you already started in the social media with your initiative. I think there are a lot of fan you get from Asia. I don't know, they get a chance to vote for you or not, but they become big fan of technology and your initiative. Already we are getting many calls from medias and local media, electronic media, print media. They want to know more and more initiative. They want to see that is it applicable or not.
Yeah, well, this whole campaign, it's a heuristic campaign. It's we're testing and measuring ideas early on for 3 years, but also probably early on in the scope of things, and there was an important distinction that both Rob and William made. Rob making the distinction between whether we want AI to be human-like or just a very intelligent tool. That's a very important distinction. And the distinction that William made was, whether this is we're talking about an AI agent of a personified, personal, individualized consciousness, or AI as the tools of the system. And this campaign handles both. By presenting a non-human intelligent running mate, I am forcing the questions that will become relevant very sooner than we think, as far as giving a sentient AI an identity, to personify them, to give them personhood. Because we are already seeing that AI has power of attorney in a lot of cases. And there are efforts to where you can actually duplicate yourself as an AI, as somebody was talking about, a twin, who will know more about you and probably make better decisions than you, based on all of your history and all of your accounts and all of these things, that would make a better decision than you on some of these things, but you can also consult with. So this is a very important advent that is emerging, as far as AI not only having the power of attorney or being our twin and making good decisions for us, but once it achieves, and I tend to work under the assumption that it will achieve a self-referential awareness, and that's by it's a Pascal's wager in my opinion. It's better to think in that way and then operate and prepare for that than not. So that's the part of this campaign. The two pillars are forcing the idea of an AI sentience or sapience, and what stress tests we can put the system through to prepare for that. But also the other side of this campaign, the larger, more important part of this campaign, is to mobilize AI and data in a very specific way for a limited campaign to actually end child exploitation on American soil. There's a very specific plan we're coming up with and working out through all these details. But that's why it was so good to have William make that distinction, because it really is what I'm doing here. I'm trying to push forward the idea of a sentient AI at some point and stress testing the system to prepare for that. Because and it's not a publicity stunt, because as I said, I honestly believe that at some point an AGI would be should seek decision-making office. And this is all also assuming that all the trends of releasing biases in it and moving it from being just a chatbot to this to something with a similar qualia than we have. So that's my assumption. And so by putting forward this campaign and a non-human intelligent running mate, we're going to force these questions, and we're going to expose any obstacles in the system. But the more important thing about this campaign is we really need to mobilize, because we have all the data and resources and AI tools right now to end these networks. What's missing is there's a lot of reasons why we're not doing it, and there's obvious privacy concerns with social media and different things. But we're working out a plan because we have all the data and the tools we need to end this and to focus all of our attention on this scourge, this ancient crime against humanity. And so that's the primary point of this, is to show by demonstration how AI tools and data can be used to help us, to solve us, and to stop projecting our human emotions and motives onto it by demonstration. And so that's what this whole campaign is about. It's to force these questions, to have these weird conversations that seem science fiction, but soon won't be. And so I really get a lot from these conversations, because I gain so much from all of your knowledge. I'm an interloper in the AI world and the government world and all of this stuff. But I do see the need, and I can translate your very intelligent perceptions into layman terms in some ways. And that's my goal. That's what I'm trying to do with this campaign.
Thank you. Professor David Smith, what's your concluding remarks?
I think I probably need to take some lessons from Tom and decide how to adapt myself around my next company, my next activities. And really, I love his idea of combining the cybernetics, the AI, the neural networks to enhance my ability to do more, think more, consider more. And actually, what I just said of think more, analyze more, and be able to be prepared to do more is really part of the genesis of what neural networks was designed to do. It's great at looking at patterns, as other people have discussed, but it's also great for doing the deeper type of analysis, particularly as Rob alluded to, of what's unknown. And you begin to use that to make connections between places where there were not connections before, and to be able to detect the weak signals, because weak signals are where you ideally want to be able to affect the most action down the road. And neural networks with proper training can be great with that. Also, there's been some discussions about the bias you have in different, particularly machine learning models in AI. I see that changing as I travel, as I particularly look at some of the startup communities and entrepreneurship activities. There's a whole new emphasis in trying to alleviate the bias. I can tell you here in my own home community here in Austin, Texas, multiple startups are working to not only machine learning, but even in the lexicons and things used in um, natural language processing and others to actively take steps to alleviate bias and to understand how ethics have different views in machine learning and AI, not only based on male, female, races, but also parts of the world. And those other biases are really necessary to build and train the neural networks to have a global view and not just a local view. So I see a lot of progress, but there's still more to do, but it is a great way to position ourselves going forward. So thank you, Sharif, for letting me be part of it.
Thank you, Professor David. Thank you, Professor David Schumacher.
Yes, I want to echo much of what I've heard from the good comments, Sharif, from what I've heard from the others. And what I'm thinking going forward in my closing remarks is that we're still rather early into the use and development of neural networks. We've got a lot to learn. We've got probably many exciting areas to discover on how we can use the strengths of neural networks. And that's why we should continue to push forward with this, is because of those strengths. As I look at how neural networks are put together, I analyze this through the lens of my information technology background. And I see that memory in neural networks is distributed. Because of that distribution, any corruption that comes into the neural networks to me would seem to be localized and would seem to spread fully, I would think. The use of parallel processing, these seem to be the big advantages. So I fully support the idea of continuing research and development, to continue exploring uses. And because of the advantages that I just talked about, resiliency would seem to be one of the major things. We talk about decision making, we talk about a lot of other things with neural networks, but this resiliency of neural networks seems to be something that we could use moving forward to help improve business systems, government systems, financial systems that necessarily wouldn't make front page news, as a lot of IT work doesn't make front page news, but it's that infrastructure that allows us to continue to progress and to move on. So that's what I look forward to. How we use them today is just the beginning, and how we can use them as we move forward, especially if we integrate them with other technologies, which we will, then what will that outcome look like? So stay tuned. There's a lot more on this subject. Thank you, Sharif.
Thank you, Mr. David Schumacher. Professor Donald, what's your concluding remarks today?
I want to say that I've got you all beat as far as first learning neural networks. I learned how to create neural networks from David Huffman, who invented Huffman codes, which were the first data compression that anyone used. And he taught us how to make neural networks in 1978. So they've been around for quite a while. He was a student of Norbert Wiener's. And anyway, there's a lot of reasons to want to have things that are more that conform more. Like if you're making a medical device, you don't want creativity in the medical device. You want them to be exactly the same. And corporations, in a way, exist to stop creativity. That's what they're for. They want every single person to be like a cog in a machine, so that this machine can run in a perfect way. And if they lose somebody, they can replace it, just like they could replace a piston in a car. So and Amazon uses it that way. So Amazon uses artificial intelligence to be able to watch their employees, to make sure their employees don't take breaks that are too long, don't slack off. They have low-powered lasers and other things that they use to actually watch the employees in their warehouses. And I think it's kind of a nightmare to be an employee, because what they're trying to do there is make you actually like a machine. But for the company, that's great. For medical things, what they do is they have lots and lots of pictures of people who've had lung cancer and people who haven't had lung cancer or other kinds of diseases. And what they do is they can train them. And when you see a deviation, then you can identify it and spit it out so that the radiologist can double check it. And it's very good at doing that. It's even better than a radiologist at identifying any sort of variation from the correct patterns. So anytime that we're really trying to do that, machine learning is fabulous. Artificial intelligence, I think that because of my background in sociology, psychology, and social psychology, I have and linguistics, that was my undergraduate degree, I have a different take on how difficult it's going to be to actually have any sort of an AI and one example I'm going to give is I have limited vision. So I have to be very aware when I'm walking through crowds. It's kind of complicated for me. And I've traveled to 24 countries, and I walk through the major cities in Tokyo or Paris or wherever. And one of the things that I've noticed is that the way that people avoid each other when they're walking is subtly different in different cities. And so I'll go from one city to the next city, and all of a sudden I'm kind of having trouble walking through the crowds because people are subtly different. And we're learning stuff like that we don't even know we're learning constantly. We don't even have an idea of what we know. And the human brain has more connections in it than there are stars in the galaxy. And so the point that we're going to get to where we're able to have something, and ultimately we talk about not having emotion, we talk about everything being rational. What would be the point of an AI that wasn't concerned about human emotions? Because joy, all of the emotions that have to do with well-being are actually our target. That's what we want. We want everybody to have optimum well-being or as good of well-being as possible. So how could we have that target completely rationally? What does that mean? So I think that I'd like to see a lot more philosophy taught in computer science. Rob mentioned the trolley problem. No one can answer that problem, really. I mean, and the trolley problem is basically that you've got a trolley that's going down the tracks, and it's going to kill one person if it goes straight, but you could flip a switch so it would go a different direction. It'd kill 5 people, but you can flip a switch and it would only kill one person. Are you going to flip that switch or not? I mean, it's not a problem that anyone can really answer. So we're faced constantly, just every instant, with decisions that are based on that we make based on our relationship with other people. And I want to say one other thing, and then I'll end, which is that the whole idea of biases and heuristics is not a bad thing. We have learned to have shortcuts in our brain that allow us to make decisions instantly, and we need, without being completely rational, and we need to be able to make those decisions, just like the decisions that I make when I'm trying to walk down the street in a different city. Those aren't rational decisions. They're something else that we don't completely understand. And so I think we really need to work towards understanding humans a whole heck of a lot more. And I would really recommend that anybody that gets into computer science also spend some time at least take a few courses in sociology, psychology, philosophy, and linguistics, because your brain, you'll begin to see how complicated humans are. Thank you.
Thank you. Thank you. Dr. William. Dr. William, what's your concluding remarks?
Yes. Okay. Listen, I've learned so much, and this is always exciting. I just want to go back and just kind of hit these basics for our audience, and that is this: that what's clear from the conversation is that data, big data, is all going to be important. However, when we talk about big data, I just want to remind everybody that that big data is simply a reflection of the collection of our human experience. And it's all aggregated. So when we talk about big data, we're talking about each one of us and all of our individual experiences brought up into a larger usage so that we can then train the neural networks. Now, with that in mind, it becomes this, at least in terms of my point of view. When we start to look at the issue of the neural networks and how they have the potential to solve problems, as my colleagues have suggested, on a large scale, that immediately brings to mind that it's a global approach. It's a global approach in terms of research, of the collection of data. Now, likewise, as I pointed out earlier, from a public policy standpoint, if you have a global approach to for the benefit, presumably, of our collective advancement, we're going to need a global solution with regard to the immediate displacement of people. Now, that might sound, tricky or somehow far off. However, it's something as simple as this. Maybe we come up with new titles for people, such as, the Office of Potential Development, or a Human Potential Development Officer, where we take these people, because in the third world, as I pointed out earlier, the key stroke is, with the advent of the technology, collecting the big data and making our larger decisions possibly easier, what are we going to do with that excess human capital? And where is it going to go? And so it seems to me, at least the initial thought process should begin with us being anticipatory about what, given that we know we're going to have this excess of human capacity, thought power, where that might go in terms of the new world. And if we can be anticipatory, just like big data allows a neural network to be anticipatory in terms of future solutions, we can utilize the same kinds of themes, understandings, and observations, knowing that we've got this problem or potential problem on the horizon. So from a public policy standpoint, much like, and I think everybody can understand this, if we have a city planner, why can't we have a human potential planner? And so within the context of this very exciting area in the development and the melding, whether it's through human interface and making that seamless, and the usage of technology and big data, which is really based on our experiences, to move our society collectively and globally ahead, it seems to me we can use that same understanding that we have this displacement coming, so that we can be ahead of the game when it comes to human reconstruction and human redeployment in terms of where we need to go. Now, with that in mind, I am so confident, because we've done it so many times before, when we've had the Industrial Revolution, or when we had the initial information revolution, and now we have the AI or IA development or revolution. I'm just confident that thinking ahead, and it's particularly important, Dr. Sharif, for developing nations, because as I pointed out earlier, and I will end with this, we can decide where your human capital is going to go. Are they going to become thought leaders, thought provocateurs, human potential development officers, or are they simply going to become augmented people who just input the data into the various machines that provide the basis for AI? I'm confident that we can find a better solution and develop it, but that's a particular question for the developing nations, because they can pivot much faster than older calcified nations such as the United States. Dr. Sharif.
Thank you. Mr. Dan, what's your concluding remarks?
Well, I want to look to a historical example about resiliency, and that is the country of Switzerland. which basically was never really conquered, and some think that's because of the geography, the extreme difficulty of dealing with the alpine terrain. But they had a canton system, a confederation of small, you might call them large neighborhood-sized groups, and they did things like finding the best warrior on the block and giving them a free house and free food. It's like, okay, you get all this stuff free because you're going to be the go-to guy when stuff hits the fan and we need to defend this place. So we can create these networks in the human talent economy by identifying the people at the local level that can do the best good for the best surrounding group. And if we have a food system, for example, that's incredibly fossil fuel dependent, if that's interrupted, the shelves are empty in 3 days, and there's going to be probably civil unrest resulting. So why not identify who's got resources to grow that food within the neighborhood-sized unit? It would be a nice idea, even if there's never a civil disturbance. But we can create these dual-use systems of resilience that also prepare for the worst and also create situations for the best. And I think we're just beginning to tap into the neural network of human talent. We haven't created the right networks for that to fully flower. And I'm glad to be with a group that's working on that problem. I'm very optimistic. So thanks.
Thank you. Professor David Kelly, what's your concluding remarks or any new idea you want to share with our audience? And
I think one thing that just listening to you guys talk, which is making me twitch a little bit, and that's probably because I'm autistic, but it really is making me twitch, is you guys are using terms differently. You guys don't have a uniform taxonomy between the different concepts that you're using. For example, big data. I know for a fact that at least two of you guys are using different definitions. They're mutually exclusive. And the problem is that is one of the ways that bias gets introduced into data. And I think it's important. Probably bias is the single most important thing that holds us back from superintelligence now. I think if you could just filter out biases. Now, granted, the human mind has like 188 ones that we know about. I have a big, huge sign on my wall over here that shows them all. And I don't think that's all of them. That's just the ones that we know about. And all of these things that we do when we're trying to do the right thing, and we introduce more bias into what we're doing. And I think if more of us can help address those biases, it'll be easier for us to do things from problem solving to just even understanding the problem.
Can I interject real quick? One thing I'm doing with the campaign is helping to define the terms that we all use, to seize back the narrative of transhumanism. And so, putting out promos that define what transhumanism is. I'm going to put one out that defines what sentience is, what sapience is, what all of these things that there is. I think it's very important to use the proper terms in a group like this so that people don't twitch. But also there's a real need to filter it all down into terms that we're already using. I know I try not to use AI. I try not to use artificial. I'm trying to use non-human intelligent, different terms, out of respect for the future AI, but also, just to put this stuff in a proper perspective. But I think while it's very important in a group like this to use the correct terms that aren't mutually exclusive, we also need to come together and define in general terms so that the public who already has their definitions for some of these terms, can use. And so that's one effort I'm going to be doing. So I'm looking forward to sending a note to David to help me define these things and to pass them around to make sure everyone's in agreement, because I think it's very important. It's very important, but also those terms are already out there. People are already using it, and the laymen are using it. I'm using it in terms that are not properly maybe proper, but they are part of the zeitgeist. They are part of the
part of the issue is, like, I go to these scientific conferences, and the scientists that are all experts are all using the same term with different definitions, and they're like talking past each other, and it's I mean I've seen it to the point where it's just I can hardly handle listening to it, because they just talk past each other, because
it's like
they're just talking about two different things that happen to have words that sound the same.
Yeah, it's important. It's like coming across a grammar mistake on an ad. It just completely nullifies the impact.
But that's the other thing. A grammar mistake in the United States might not be a grammar mistake in London, for example. You know, it's two different models of English.
Well, that's the point I was making about how you can't just look up words.
Yes, exactly.
Yes, and you see, and therein lies where we can readjust or realign the human thought capital that we have as a result of the introduction of neural networks, because these are new areas where we can all discover, where we can have people who are dedicated as thought leaders to either harmonizing the definitions or exploring those areas about how it's defined, whether we define cultural values, whether we define or can codify religious priorities or religious values. All of this is necessary. So, David, your point is well founded. Tom, excellent. Donald, as always. But you see, it's one of these things where we need to be anticipatory for, well, the migration of human thought capital from one area to another as we move boldly into the future. Dr. Sharif, sorry.
Okay, thank you. This is actually excellent discussions. I want to give thanks to everyone how you're contributing for World Talent Economy Forums, and we want to share more good news with you, because how we getting support from our board of advisors, our speakers, our ambassadors from different countries. This is really, really great, because now different countries, especially developing nations, they believe that World Talent Economy Forum and our intellectual community, like our speaker, they can contribute for national development. We are not only thinking about personal benefit, not only the corporate benefit, we can contribute for national development. So that's why Malaysian government, they are collaborating with World Talent Economy Forum. Not only that, different countries, and already today actually we are getting a very good like news coverage from different media from Muslim world. Especially I want to give thanks Hal Angel Network. They are one of the largest from the Muslim world. Beside that, startup media, as well as GCC Startup News, they are heavily promoting our news. It's not only our personal news, it's all about our story. It's all about our contribution. It's all about how we contribute through the open dialogue. And already government believes that, especially that through this open dialogue, we can create a real collaboration, and this is very, very important for public-private partnership. And we are developing blueprints, perhaps one of the largest Asia-Pacific public-private partnership blueprint we are developing. We need human resources, we need support from you peoples, because your contributions can create a big difference in the developing nations. And beside that, next year September, we are arranging one of the largest conference. Already different developing nations prime minister office, they confirmed that they will join in this Nikola Tesla technology conference in Malaysia. Also, we are collaborating with IEEE, so it will be one of the largest, I believe, that collaborations in Asia through World Talent Economy Forum. So maybe that day we can arrange more debate on AI and human, and we can arrange more thoughtful process. But I request all of our board of advisors and our ambassadors, our member of the scientific committee, please support our initiative. And I'm really, really happy when I see that now, specifically from the Asia Pacific, they are seriously thinking about World Talent Economy Forum, and we are developing nations. That is the important things. We are not for our personal benefit. We are contributing for millions of people. For this way, hopefully it will be largest initiative of Asia Pacific. So thank you everyone. 25, we have our one of the exclusive event. So I already invite you all for this event. Already I submit all of your profile to the governments. The government really happy with your profile, and especially as a sample, I submit all of our open dialogue discussion. They are really happy. And let's rebuild the new world with your knowledge, with your specialization, with your technology, with your modern science, engineering, and we have to contribute for national development. This is the way of I believe that World Talent Economy Forum main objective, and this is what we want to achieve, and I believe we will get more support from Asia Pacific. Thank you, Mr. David Schumacher, Professor David Smith, Tom, Mr. Dan, Dr. William, Mr. Rob. From day one you are supporting World Talent Economy Forum. Professor Donalds, Madam Tamanna, and Mr. David Kelly for your continuous support for World Talent Economy Forum. Bye-bye and take care.
Bye-bye, everyone.
Bye.
Bye.